that you've chosen an ECU, decided on an installation method, and fitted the ECU to your vehicle, we want to take some time to look at the tools that are required to perform the tuning or calibration job. While some of the tools are absolutely necessary, some of them are just nice to have and will be helpful in making your life easier. Let's start at the top. First and foremost, you're going to need a laptop. You're probably watching this video on one right now. The laptop allows the user to connect to the ECU through a communications cable so that you can make changes to the calibration. Ultimately, it's this calibration that tells the ECU how your engine behaves and characterises the engine's airflow and fuel flow requirements. The next thing you're going to want to have is a wideband air-fuel ratio meter. Whether it's built into your ECU, a standalone unit, or attached to the dyno that you're using for tuning. It's the wideband that gives you the largest piece of information. Is the fueling of the engine being scheduled correctly? If it's not, you can make changes to the calibration to suit. Now, in the initial tuning process, you're going to want to make sure that the ignition timing the engine is actually running and the ignition timing the ECU thinks the engine is running are the same. For example, the ECU might be asking for an ignition value of 10 degrees before top dead center, but if you haven't synchronized the engine with the ECU, the engine could actually be running any timing value. We'll need to use a timing light clipped around the spark plug wire or high tension lead attached to the coil for cylinder 1. When we crank the engine, the timing light will strobe or flash and show us a mark on the crankshaft that indicates the actual ignition timing. Once we know the actual ignition timing, we can synchronize the ECU with the engine using a trigger offset angle. Now, there are several different styles of timing lights available in different price ranges and qualities. Some of the fancier lights have a dial back capability, where there's a timing circuit built into the timing light that creates a delay between when the spark event occurs and what the strobe light displays on the crankshaft. So you can actually turn the light backwards and essentially count the number of degrees from when the engine was at top dead center. This time delay circuit can cause a problem with many aftermarket ignition systems, so it's preferable not to use a dial-back timing light. Just use an inexpensive but reliable timing light that's available in your area. A lot of tuners like to use some style of knock detection, whether it's a knock sensor connected to an ECU, a standalone unit, or a set of headphones commonly known as knock ears. In any case, knock is an adverse condition that you don't want your engine to encounter. The sooner you can detect a knock event occurring, the sooner you can make a calibration change to avoid it. One of the safest and most accurate ways to tune an engine is to use a dynamometer, or dyno for short. A dyno is a tool that allows you to simulate different road-going conditions, going up hills, going down hills, accelerating and decelerating. But at the end of the day, what we really want, whether you're buying a dyno or simply renting one, is the ability to have steady state load-bearing capabilities. What that means is that the dyno can hold a specific engine RPM, and as you open the throttle, the engine makes more torque and more power, but the dyno will hold the engine at the same RPM. In this way, we can travel through many different load sites for the same engine RPM. Imagine a scenario where the engine's operating at 3000 RPM going up a steep hill. You'd need a substantial amount of throttle opening to maintain this engine RPM. However, when we get to the top of the hill and start going down the other side, the throttle would almost need to be closed to achieve the same 3000 RPM. This represents two dramatically different engine loads for the same engine RPM. Because the engine has the capability to operate at these different load sites, we need a dyno that can maintain a constant RPM while we vary the engine load using the throttle. In this way, we can steady state tune all load sites across all operating RPMs of the engine throughout our calibration process. Whether you're using a chassis dyno or an engine dyno, whether you're using a water brake, a hydraulic, an eddy current, makes little difference, just as long as the dyno is capable of holding a steady state and bearing the load. Some other common tools that may be handy when you're testing and calibrating engines are a multimeter or voltmeter, and an LED test light. These are tools that are used for diagnostic testing when things aren't going that well. To test if an injector is receiving a signal from the ECU, we would use the LED test light, which would flash each time a signal is detected. But in any case, these will be nice tools to have in your toolbox so that when the time comes, you'll be able to quickly and easily identify a problem.